again, just to be very clear, so everybody is on the same page, we are not quizzing tomorrow. We're going to quiz on Monday. Everybody's got that. Okay. We're going to go over our workbook problems from 1B and 1C today. I will let you know, I said this before, but these are intended to be part of our learning experience. So whether you have it all right or wrong is really not of consequence to me in this case. Okay. We're going to write on them. We're going to define some things on them. So have your pencil out, be paying attention this whole time so that we can make that a productive use of our time. And again, we'll talk about some of this other stuff tomorrow. I want to make sure that we have time to actually talk about this. So this is 1B, the first side that you did. This was the one talking about Angela running to the bus again. I guess she's just always late to the bus or something. I don't know. Yeah, it's not about, but maybe we should change the names on these, huh? So we're finding some pretty straightforward numbers here, right? We can just plug in numbers there and get that, and then we can graph it. Again, pretty straightforward. Questions on that graphing process or any of that? Any issues that you had? So you got a nice slope that went through. I'm just going to kind of like eyeball it here. It did end up going through the origin, didn't it? Yeah. Which was convenient.
And it kind of went through the points too. We should have gone through all the points.
Yeah, it did, because it was something kind of pretty consistent like this. Yeah. So cool. So you're going to actually plot the points, all of that sort of thing. It was nice that they gave you all of the like the values in that. So it's pretty sweet deal. Really, the things that I want to focus on are these things down here. Okay. So a couple of things that I would encourage you to highlight, underline, glitter pen, whatever it is that you use to make sure that you're paying attention. This would be the time to get that out. A couple of things to pay attention to. We're going to choose two locations on the line that we can use to calculate the slope. And it says here, and I want to reiterate, do not use points from the data table in order to find the slope. And I know, because I've looked at the data, that it's not super easy to find non-data points that are on nice grid lines in this particular example. But regardless of how hard or easy it is to find data point or points on the line that are not data points, you have to do that. Not negotiable, okay? I should say, you have free will. You can do whatever you want. If you would like to earn the maximum amount of points from College Board to prove to them that you understand how to do this, then you should definitely not pick data points, okay? So you're going to pick points that are not on there. So you're going to find places. And I know that, like you just said, most of them are, most of the crossing points are places that you saw. But you can pick something like this that's kind of in the middle, and you can estimate that. I usually put an X on the points that I'm going to use to solve or find my slope. You can also circle them if that makes sense to you. But you're going to find a couple of those that you can do a decent estimate. And then I would also, just for good measure, either write them like this with the coordinates, or I would put them over somewhere so that when you're calculating your slope, it's very, very clear what values you're using. The more clarity that you can provide there, the better off you're going to be. What did you guys get for a slope? Just to make sure we're all on the same. 3? Yep, 3 meters per second. Yeah. Awesome. Fantastic. So yay, we can do that. Now we're going to figure out what the slope represents, and we're going to take and extrapolate a little bit further here. So the slope of the position versus time graph, we've been saying this for a few days now, represents velocity. Yeah. And we know, because we are clever and because we're going to love the y equals mx plus b form of a line, that we can make this into an equation. What does the equation look like?
Y equals 3x plus 0.
Love it. Everybody okay there?
Yes.
Okay. Hopefully that makes sense to you. And if it doesn't, then either speak up now or let me know, because we need to make sure that this is okay, that this form is okay. All right. And then the more generalized equation that we can use, given this stuff, I don't know what you're doing. Go away, please. I don't want to know about my people. I want to do physics today. There we go. Using these variables, we can plug this in. So what are we going to have? Letter. What's going to be there? Velocity equals what?
X times t.
V equals x times t?
No.
That's not a true statement, is it?
No, I actually.
It's not a true statement. So and I'm no criticism. I just want to make sure that we're paying attention. Now, they were trying to lead you to a place, and I want to show you where they were trying to lead you. What's on the y-axis here, friends? Position. Meters, right? Yeah, that's the displacement. That's what's going to live there. Okay? Yeah?
Yeah, that's what I have initially.
And then what thing lives here? That's the slope. And the slope is the velocity, right? They're kind of trying to slow walk you there. If you just trust in what's going on, don't overthink it, it will often get you to the place that you need to go without even having to try super crazy hard, okay? That's what's going on. You can also double check that because we've been using this equation V equals delta X over T for a few days, right? If you get rid of that denominator, see you later denominator, and I'm talking because the same conversation happened in the last class. Because people just want to it's gotta be, it just doesn't.
No,
yeah.
I played myself because I had that. I had that
Love that you
first,
said
and
that
then I get really unconfident, and then I change it. So, she knows.
So if that happens, which totally could, and I totally understand it, what's the best way to double check without having to overthink and overcomplicate your life? Any ideas? Formula sheet? Maybe. What if I don't have the formula sheet nearby? Or what if I'm taking a quiz and I don't know any of the things and I'm like, oh, blah, blah, blah.
Plug in numbers.
You could plug in if you have numbers. That could work. Let me give you one other suggestion. What about the units? When you were in chemistry, did they teach you something called dimensional analysis? They might not have called it that. Have you heard of that, dimensional analysis? It means look at the units and see if they work. Or look at the units and use them to solve the problem. It's a beautiful thing. If we look at the units of this thing that we've crossed out, that would be meters per second, right? That's velocity. Is that equal to meters times seconds? No, it's not. Which means that there must be something wrong. Say, doesn't work, try again. This one that we have down here, this is meters equals meters per second times seconds. Does that work? Indeed it does. Because you've got seconds on the bottom, seconds on the top, leaves you with meters. Done and done. Dimensional analysis is your friend, friends. Okay? Pay attention to it. Units are the best. Other questions on 1B? Let's do 1C. This one has got some definition words that we need to make sure we're paying attention to, okay? It doesn't look beautiful in here, but you'll get the idea. So it says a toy company has developed 2 toy car models, A and B, where the average speed of each is identical. Each group of students is given 2 toy cars, one of each model, meter stick stopwatches, and asked to test the toy company's claim. All right, so I guarantee you, when you're taking your AP exam, that one of the free response questions will be an experimental design opportunity, okay? Where you will get to write down how you would do something, what the procedure would look like, okay? A couple of notes, a couple of things that I would absolutely pay attention to. One is to be concise. What does it mean to be concise? Get to the point. Say it in as few words as possible. And that doesn't mean don't say any words, but it means choose your words carefully, right? Get to the point and do it, okay? In that vein, I want you to look at what it says. It says here, cross out any extraneous steps and order the remaining procedural steps, okay? Go ahead and take a minute to chat with your table mates. Compare your answers. See if they agree with you.
I was debating hardcore between crossing out the first one. Yeah, so we have first and third, so we talked about it.
All right. So let's take a look. It says cross out any extraneous steps and order the remaining procedural steps. So before we get too far here, we need to make sure that we understand what extraneous steps means. What is extraneous? Steps you don't need.
Steps that you almost like you do, but you don't need to include the procedure.
Yes. So sometimes they'll put in steps or you might include something that is not necessary, right? So it could be not needed. But more often than not, extraneous really means extra, but they're like things that you would do anyway, right? So like, tell me the procedure for the buggy lab. I walked in the door to the room. I sat down at my seat. I got out my Chromebook. Like, these are not things that need to be in the procedure, right? Extraneous steps are things that you would do anyway, but that you're going to do in most labs, right? That's what we're talking about, okay? So we'll say not unique to this experiment. Now, there's one exception to that, but we'll talk about that in a minute. Do you see anything up here that looks extraneous, extra? We don't need it.
Gather equipment and draw data table.
Gather equipment. You're going to gather equipment in every single lab, right? Like, how do you do a lab without that? So, yeah, so gather equipment. You don't need it in your list. And you said another one. What else did you say?
Draw data table.
Draw a data table in your notebook. Like, again, whatevs. Anything else?
I also put repeat to reduce error because that's like you're doing multiple trials anyway.
Right. So here's the thing, because I agree. Based on this definition for extraneous error, that's not unique because you should do trials and everything, right? But my experience has taught me that when you're writing an experimental design problem, almost without fail, and I have not looked at every single experimental design to double check this claim, but I'm pretty darn confident that every time you write an experimental design, you need to include that you're doing multiple trials, because that is so important to the process of science that you have to include it, okay? So even though that may sound extraneous, because of course you're gonna do it, you have to include it if you want the points, right? And again, free will. You don't have to do anything you don't want to do. But if you would like credit for knowing how to do physics, then you need to include it. So we're going to say always include the multiple trials. Yeah, go ahead.
Another one is the first one a little bit redundant because if it says 1, 2, 3, 4, the fourth one measure and record the time the car took to travel. I feel like that's kind of something as the first one.
It kind of is, although I think you have to physically put the car down first.
Yeah, but like people do that anyway.
Yeah. So to me, I feel like you kind of still do need this.
Okay.
Let me kind of twist it around in the way that it's really going to come back to you.
Okay.
And that is that when you are asked to do this on a test or a quiz or an AP exam, you're not going to have steps to put in order like you do in elementary school or middle school or even, in this little example.
Mm-hmm.
It's going to say, write a paragraph length answer to describe your procedure. So in that case, if you didn't say them as separate sentences, it would be okay, but probably you would say something about releasing the car, like maybe not the turn on the car.
Okay.
Is that kind of where you
Yeah.
were kind of, yeah. So that's that, yeah. Does that make sense?
Yes, it does.
Awesome. Okay. I think these other 4 are okay. What's the order? Help me out, quick.
1 for measure a 2 meter long path and 4.
1 for measure a 2 meter long path. Oh, hello.
I'm unconfident.
No, you're right. I just need to my stylist doesn't love to play today. Measure a 2 meter long path. Wake up. There we go. Number 2.
Turn on the car.
Turn it on. Step 3.
Measure.
Indeed. And repeat. Yes, rinse and repeat. All right, we good? Okay. So then we do the data analysis. So hey, look, they did this. They collected some data. This is super common. I love this. Yep. Given the data set, talk to your table, not to the table, to the people that are sitting around the table with you. Okay? See if you can come up with an answer, both a check mark and an explanation. Go quick.
Okay, I saw the first one. Because the cars
It's
all
car-
the
it
different
goes
speeds.
faster.
Do
It's faster
basically
than
every
anything
time.
else.
Do we try out loud? So I felt really stupid.
So how do we feel about the answer? Do the cars have the same average speed or no?
Yes, they do have the same average speed.
Yeah? Does everybody agree that they have the same average speed?
I mean, definitely missed
It's
some.
right there. I really hope.
I mean, these two numbers match. Yes? No, I mean, they're not gonna like.
Okay.
They're not gonna monkey with it. So yes, these physically do. Look at the data though.
They do not
There's
have.
outlier though.
What's that?
Number 5 the outlier.
Yeah, team 5. Like, I don't know what they were doing.
I don't know.
They must have been out to lunch during the instruction time. Like, I do not know. Do you see, friends, that team 5, like,
Yeah.
who knows what was going on with them? I don't know. Team 5 needs to go learn how to do some physics or something like that. Team 5. This is an outlier.
It's
Oh, I'm sorry. You can't see the cute little orange line I drew. There you go. Bam.
Should we add?
What's shaking?
So if you're doing a lab and you have some like really bad outliers, can you just like completely omit it?
Heck yeah. I mean, I should say, let me back up. Let's say that you were doing, like, I'm just gonna, because this is a line, right? So you have like data, I'm just making stuff up here like this. Then you have one over here. Like you would put it on the graph, but then when you're drawing your line, you would say, just like that.
And then, do you like calculate it for averages?
Nope.
Or-
Nope. You say, that is a terrible point.
Oh, then they do.
We screwed up. Like something happened. We can acknowledge that all of this stuff has a trend except this goofy one. Like we must have bumped it. We must have closed our eyes and taken a nap for a little while. I don't know whatever happened, but something happened. Yes. So I'm going to say team 5, lab group 5, like, I don't know what they were doing, but they are definitely an outlier. If you take group 5 out, what do you see?
They are not.
Decidedly not the same. Decidedly not. The cars have different average speeds. How do you know? What's the rationale? When you remove the outlier, the average speeds are very different.
Yeah.
Oh, stop. This is why we do this, right?
Yeah. That was really weird.
It's all good. When you remove the outlier, the average speeds are different. All right. Can we keep cruising?
Yes.
All right. We got 8 minutes. This is a big deal for 8 minutes. Here we go. All right. Pay attention. Stay focused with me here. We got a lot to do. All right. Part C says the students decide that additionally they want to test the toy company's claim that each car's speed is constant throughout the motion. How, if at all, does the experimental procedure from Part A need to be modified to verify instantaneous speed? So here's the thing. We haven't talked about instantaneous speed. We need to do that right now. Here it comes. The opposite or the other of instantaneous speed is average speed. So average speed is what they were looking at before. Instantaneous speed is what they're looking at in this part. What's the difference?
Average speed is.
Average is well the average of all these different speeds, and then instantaneous is the speed at specific time.
Okay. So instantaneous, you said, is the speed is at a specific time. Whereas the average is what? Say that again.
Just the average of all the effects.
Okay. Kind of like the overall. Are instantaneous and average speeds the same? Could they be the same?
Yeah.
Sure. If I am on the interstate driving between Iowa City and Des Moines, ignoring like my getting on and getting off, my average and instantaneous speed are probably about the same, plus or minus a little tiny bit, because I put it on cruise and I just go, right? Okay. But that doesn't mean my average and instantaneous speed are always the same. If you drive down Dubuque and you have an average speed of 35 miles per hour, Does that mean that at every moment while you're driving 35 miles per hour? Decidedly not. It could be totally different. You might have to stop because somebody's turning. You might not be paying attention and start going a little faster than maybe you should. I don't know. Not going to judge. A little bit, but not a lot. Okay? Instantaneous speed is exactly where we're, like how fast we're going right now. What measures that, like in your car? The speedometer, yeah. Anytime that your average speed matters, miles per gallon, kind of. I mean, ish. The thing that I was thinking of is not totally unrelated. The thing I was thinking about was like when Google Maps calculates your estimated time of arrival, right? Like it's not going to take into account the fact that you're going to slow down because you're behind a really big semi, or that you're going to speed up because you're going down a hill or whatever, right? It's just taking your overall, right? Your overall speed. So that would be that I think about like when calculating arrival time. Does that kind of make sense? Yes. Okay. All right. So that's an important distinction. I'm glad that you kind of get that. Okay. So now we want to measure instantaneous speed. We've got 2 more things we've got to find out about. We've got 4 minutes. I totally think we can do it. So Angela thinks that they should use a motion sensor to collect speed versus time data. So let me tell you what a motion sensor is, because you probably have not had the opportunity yet to use a motion sensor. We will get to use them in class in a few days, but not quite yet. So a motion sensor is a little contraption that sends out sound waves, like sonar, sends it out, and then it bounces off of an object and it comes back. And from that, a motion sensor can determine position. I'm going to put this up here. You write this down too. Can measure position, displacement, and velocity. Much like a bat or a whale. No, not whales. Dolphins. Right? It uses sonar to do that. Okay? So Angela thinks that she can use this to graph the speed versus time. And if you've got a horizontal, if that is horizontal with a 0 slope, then the instantaneous speed is constant. Blake thinks that they should use a photogate. Does anybody know what a photogate is? Have you ever seen or heard of photogates?
Can I give an estimate?
Go quick, yeah.
Is it just an estimate, I guess? Like a photo's taken and then it's like all together? No?
Kind of. So photogates are actually physical things, but it's kind of the same thing. So it's kind of like a go and a stop. So like we're going to use them again. And so a photogate, like you go through it and it starts the timer, and then you go through it and it stops the timer. So you can imagine driving down Dubuque. If you have, if one person is standing at the exit to Liberty, you have another person standing at the interstate, right? And they go and they stop. That's kind of what a photogate is doing. You know the distance, you know the time, you can find the speed, right? Yeah. But does it measure the instantaneous speed or the average speed? Average speed, right? So photogates measure position and time and are then used to find an average speed. So, average speed, instantaneous speed. Which one's a better choice? Angela wins. Yep. Jeez.
Do you sing?
That's what we're thinking.
Wait, is he higher?
How are we doing? Are we okay? All right. Would you guys put up as many chairs as you can between now and the time the bell rings? I would so very much appreciate it. Thank you guys so much for your hard work today.
Are the pendants all the way to your